And then let's share screen. Okay. All right, can you guys see this? Can I? Okay.
Yeah, we can
thumbs up.
see it.
All right,
Yeah.
great. Thanks. Okay, so well, I hope everybody's doing well and having a great semester. My name is Abir, and today we'll be talking about Git and GitHub, two of the leading technologies in version management and version control. So to start off, Git is a version control system used to manage projects and track changes over time. So around, pretty much 20 years ago, the founder of the Linux kernel, Linus Torvalds, started having more contributors to his work, and he needed a way to be able to work in unison with not in unison, but I guess the opposite of unison, work simultaneously with these other contributors. So came along Git, which is a technology that he developed, where a working directory serves as a full-on repository with version tracking, branches, and many other features, and all of which are independent of any central server. So yeah, this is just the standard description of Git. It's a free open source distributed version control system designed to handle everything from a small to a very large project, all with speed and efficiency. So, yep, as I told you guys earlier, Linus Torvalds, pretty much the creator of Git. And it's often referred to as this global information tracker, and more on this later. And one of Linus's quotes, he has many critiques about GitHub, which we'll also get into more on that later as well. So yeah, Git is one of those tools that is used for collaboration, time travel, and by time travel, I mean you can go back to previous versions of a project, documentation for, adding instructions about various changes and updates in your code, and many more features. So now comes along GitHub, which was an independent company, which is now owned by Microsoft. And they offer cloud hosting for Git repositories. And that quote from earlier was actually one of Linus's critiques towards GitHub. He created Git, but he's not necessarily a huge fan of GitHub. He's known for liking its storage capabilities, but he hates several features, mainly some called the pull request, which we'll get into that a little bit later. So yeah, GitHub is a cloud-based hosting service that lets you manage Git repositories, as I said earlier. So a good comparison to GitHub is actually Google Drive. Google Drive is a great way to host, several written documents, spreadsheets, and slides for presentations and whatnot, and which can all be stored in several folders and whatnot. Similarly, in GitHub, you have repositories, and in these repositories, you have your code base and your various dependencies, actual code files that make up your project. And this repository can be stored in a project, which is pretty interesting. So here are a few of the important features that we'll touch upon. So one, staging and committing of changes in a repository, branching, merging branches, and reverting to previous versions, and also pushing and pulling code. Okay, so let's start with staging and committing. So this process takes place when you clone your repository or pull code from it. So you'll make some edits and then save your changes locally. Locally meaning on your system, your computer, which is within that one working directory. You can then add these to the Git repository. So once you've added them, they're on the Git repository, but locally. Once you commit, then it essentially goes into the, I guess you could say the GitHub repository, the thing on the cloud. And this is essentially where you're telling Git that this is a new version or that there's been some update or fix to this code base. And after this presentation, I'll be giving a demo of how some of this stuff works. So we'll get into that more later. Okay, so yeah, you have your initial save. And then on top of that, you can keep having these new saves and then commit. And so we have this initial commit, and then you can commit as many times as you want. There's several projects that have commits going into the thousands if they're really large open source projects. So yeah, so next we have branches. So with branching, you are essentially creating a version of the repository within the repository itself. And the changes, so yeah, here we have this master branch. So when you create a repository, you generally have one branch that's referred to as master or main. And you can create as many branches as you want. So we have the master branch, and then we've branched off of that. So let's just assume that this was one of our initial commits. Then we committed something, and we specifically branched off of this commit. So we have this new branch right here. So any changes made on this branch, they will essentially be independent of this master branch. So this allows, people to work without any conflicts on the same code base. So yeah, as you can see, we have a new commit mainly only on the new branch. And then we're also committing on master. And these changes are presumably different from what's being done here. And then we have what's called merging. So a neat thing about these branches is that eventually you can merge two branches together. So you can conjoin the code. Essentially, anything that's duplicated is fine. It only takes one version of that. And if there's any conflicts, you can manually go through and resolve those conflicts, if you will. Choose which version of the code you want. And yeah. And also another thing that we have is reverting. So you can also revert to a previous commit. Say, I believe there's this feature where you can sort of blame a particular commit. So in that blame, what you're doing is saying like, hey, it caused some bug. So say, yeah, this commit right here. Also, quick note, can you guys see my cursor or my mouse cursor?
Yeah.
Okay, great. Yeah, so for example, here, let's say that this commit was giving some issues. So we can revert to this previous one. And rather than, so one neat thing about GitHub, or Git, if you will, is that you're never really deleting any of your commits when you revert. It sort of makes it like an invisible commit, if you will. So yeah, so you have your GitHub repository and your local repository. So I think it's safe to assume that all of what I previously said is in relation to your local repository. You can publish all of these things to GitHub through pushing. So generally the first time you create a repository and you want to add to it on the GitHub repository, it'll ask you to set this upstream origin. So you set that origin, and then it allows you to push your code to this repository. Yep. And another thing is changes that were made on the GitHub repository that you don't necessarily have on your local repository can be pulled through this simple command called git pull. And you can, as I said earlier, you can push changes from your local repository to GitHub repository. And of course, the merging takes place in your local repository, and then you can push a merge or publish a merge, if you will. So that was a pretty quick presentation, but are there any questions? I'm also going to go into a live demo right after questions. So any questions, feel free to ask, or during the present or the demo as well. Anything will is
All
welcome.
being done at a terminal.
Sorry?
Like is this all being done at a terminal? The git pull, git push.
Yeah, so it can all be done within your terminal, or I believe GitHub has this really neat desktop app that you can use as well. I've personally used both, and I can show you how each of those works. And there's a specific terminal. It's called Git Bash. So Git Bash is where you can actually clone a repository and then, start working on it, and also use all those Git commands. So yeah.
It's definitely still possible to use like command prompt, for example, like with Windows,
Oh yes, of course.
as long as it's in the environment path, right?
Yeah, if you're within that working directory, that working directory is recognized as a Git repository, and then you can use any of those commands.
Yeah. I also added like a helpful like 10-minute quick rundown of like it goes over like Git's basic commands and stuff like that. So
Great.
handy little link, but
Yeah.
yeah.
And I will also share something with you guys too. It's this GitHub cheat sheet for not all of the commands, but most of the commands that you'll probably end up be using at some point. So yeah, I guess we can. So before we get into any actual demo, I'll show you what it's like working in a repository with multiple contributors. So over the summer and even a little bit currently, I've been working for a company, and we have several repositories, and not several, but 2 repositories in our project. And this is a private thing, so nobody can really access it. So here's a history of all of our commits. And as you can see, we have, these commits could be anything from fixing a bug to updating or to just adding to the code base. So yeah, it's just a whole long list of messages and stuff. And another thing that's neat is you can click on any particular commit and see what's been added, what was added in this commit versus what's already there, which is in red. So, I mean, yeah, that took you back to the early days, but if we go to, that's how it is. And what's neat about this desktop app is it just makes, you don't have to use any of these commands in the Git Bash terminal. You can do everything from here, and it automatically keeps track of when you've made changes. So yeah, now why don't we go ahead and make a new repository for this demo. So yeah, this is one of my GitHub accounts. So I'm going to go ahead and create a new repository. Let's call this Google DSC demo. Okay. And then, yeah, we can go ahead and make it public. So when making a repository through GitHub, you have a lot of options for things, additional features you can add. So a README file, of course, is like a longer description, which presumably you will add instructions on running or using your code base. You can use it git ignore, which is actually really useful. So when you push anything or publish anything to a GitHub repository, any valuable or private information like an API key will be ignored, so it won't be published. And you can also choose a license. So as it says here, a license tells others what they can or can't do. So like if I were to choose a license, I have this long list of, possible license, and they each have different, different constraints and capabilities of what you're able to do. Say if you are to, clone and use somebody else's repository. I mean, and publish it, presumably, if you're able to go forward and do that. So we're not doing anything with this repository that's needs to be protected with the license. So why don't we go ahead and create it? Okay, so now we have two options to actually go in and work with this repository. So setup in desktop, I believe that allows you to import it into your desktop app, and do all the cloning, not cloning, but pulling, pushing, and things like that. Or one thing we can do, and what we will do for this tutorial, is copy this, and within our git bash terminal, we will perform the cloning. And one thing, in order to really work with Git on your computer, you'll want to get Git installed. So wait a minute, I'll show you a website to do that, Git installation. So yeah, let's go to download, and it's a pretty simple standard website, not too fancy or anything, but I'm just going to include this in the chat. And yeah, let's get back to it. So let's go ahead and do the cloning. All right. So from this website, from GitHub with this repository, I copied essentially the HTTPS URL. So let's do git clone, and then let's paste this in. So paste, cloning. You appear to clone an empty repository. That's totally fine. So now why don't we go ahead and open a VS Code. I would, for working with, Git, VS Code's really neat because you can always, I mean, you could do this with any editor, but you can have a Git bash terminal or Git bash console as your terminal. So we will close this folder. This is some work I was doing for something else. And we can now open a folder. So let's see. What did we call it? Where is it? Google DSC demo right here. Okay. So let's go ahead and select this folder. And yes, I trust this. Okay. So we don't have anything. Oops, what did I do? All right. Yeah, so what can we do now? Let's open a terminal. And we don't really have any code to add to it, but we can at least show the principle of branching. So I'm going to quickly pull up that cheat sheet. I still use it, even though I've been using Git for a while. And let's see how to create a branch. So what we're going to do is git checkout, and I believe we add -b, and that is how we will create this new branch. So git checkout, and let's see, what should we call it? Let's call it test branch. Okay, so yeah, now we're in this new branch called test branch. So let's see how we need to. So this change currently is only reflected on my local repository. We need to figure out how to add it to our GitHub repository. So why don't we try git add and then a period, which is essentially adding everything. Okay, so let's do git commit and then -m for a new message. And let's say test branch added. You can type whatever you want here. It's just a commit message. Nothing to commit. Okay, on branch, test branch. Huh. Right. So if I were to do git push, so git push set upstream origin test branch. Uh-oh. Failed to push some rest to, huh. Looks like we're running into some technical difficulties. Huh. All right. So that didn't work as expected, but for the purposes of this demo, why don't I go to some existing thing that I already have. I'll open up some other this puzzle algorithm, and this puzzle algorithm isn't my code. I forked it from somebody else. So one neat thing about GitHub is you can fork other people's repositories. So what you do by forking is it allows you to make edits to that repository without needing their permission. That's a bad way of saying it, actually. It allows you to create a copy of their code. So when you want to publish or change anything with it, you essentially won't run into issues of being blocked. So puzzle algorithm, let's open that. So
yeah,
yeah,
I have a quick question. So for what is the difference between cloning and forking then?
Yeah, sure. So what you're doing when you clone is you're just taking a GitHub repository and you're cloning the code, meaning that you're essentially downloading it onto your local machine. So you're creating that local repository on your local machine, if that makes sense.
Yeah, so then what about forking? Like,
sure, let's go
forking?
into forking. So let's go to some random repository, okay? So explore autocomplete. So as you can see right here, we can so I could clone this repository, but if I try to make any changes when I clone it, I'll probably run into some issues of I don't have permission to, commit. I don't have a permission to add to this repository. So that's why I instead will fork it. So I can choose where I want to fork it to. This is just my main account. So now,
like, I guess forking is like making a literal copy of.
yeah, precisely.
Cloning is like you're a part of it, but it's just downloading it to your machine.
Yeah. So now it's forked. So you see, it's a beer Karande / autocomplete rather than with fig / autocomplete. I forked it from there. So now I can go ahead and clone it, and then I won't run into any permission issues. Good, great. So yeah, I guess that goes over forking. So as I was previously doing, so let's go back to that puzzle algorithm and demonstrate some other stuff. Puzzle algorithm. Okay, I believe I do have and also I'll show you guys. Actually, yeah, I'll go ahead and open up. Let's see, what are we looking for? Puzzle algorithm, here we go. So yeah, so now we have some code here. This is, I forgot what this was used for. It was like some encryption thing and all I simply did was add a key to it. So we can go ahead and create a new file. Why don't we call this test.js? And we're just not gonna worry about adding anything here. We can say console.log hello Google DSC. We're not going to print out anything actually, but because we're not running it. But let's make a change here. And first, before we do that, let's make a new branch. So let's call this test. Okay. Now, let's just add another print statement. So console.log works. Okay, now let's save these things. Now let's go ahead and add them to the repository. Okay, they've been added. So git commit test commit. This should work. Yep, so now, as you can see, we've created a new commit. The message is test commit. So 2 files were changed. And we created one new file called test.js. So this file was changed and this file was changed. And I'm not sure what exactly we deleted, but that's not a big issue. So now that we've committed, let's do a git push. So it's going to ask us to set an upstream origin. So let's go ahead and do that. All right, so it's going to push to test rather than, what is it? So now that we've pushed, let's go to so we have the ability to compare and pull request. So yeah, this is just the deletion, and this is this right here is what was added. So yeah, there's nothing that we need to do. Essentially, when you create a pull request, you're essentially choosing whether or not you want to, how should I say this? If you want to add it. So yeah, let's go back and see. Yeah, so now we have 2 branches on our test, or sorry, on our puzzle algorithm repository in the GitHub repository. Sorry, I'm just throwing repository around. And let's see how many branches we have. I think it's just these 2. Yeah. But yeah, I guess that's a pretty unorganized explanation and presentation, not presentation, but demo of how Git and GitHub works. So any questions? Feel free to ask anything. Okay, well, in that case, if there's no questions, then I think we're good to go. Yeah, well, thank you everybody for attending, and yeah, I mean, have a great weekend, and yeah, good luck with the rest of this semester. I'm sure I'll be seeing some of you guys later on for other events that we have. And yeah, so.
Also, Beer, where can we find the recording for
Yeah,
people who...
so I'll just share my screen again. 1 second. Okay, so if we go to YouTube, and then if we do, this loads UVA DSC. So UVA DSC, so Google DSC at University of Virginia, we have all of our recordings. So like last year's version control, and all previous recordings are also here. So if you ever need to refer to anything, and this recording should probably be up later today. And yeah, I'll probably provide the link in the Discord. So. But yeah, once again, thank you for coming, and I think I can, yeah, I think I can stop the recording and we should be good to go.